Chapter 14, Sample Problem Number 5. 2-point sources can generate waves with the same frequency and amplitude. The sources can be turned on or off individually. Part A, rank the intensity of the wave at the labeled points if the left point is on but the right point is off. So really ignore the right point source. And so we're going to fall back on or use that the intensity of a source is relative to some initial place is proportional to the inverse of the squares, because it's going to be some power over 4 pi r squared and the same power over 4 pi r naught squared. And so we end up saying that it is the ratio of distances squared. So if I double the distance, I have 1/4 the radius. So if we look here, we can say that, well, B is the closest for sure. And so B is definitely going to be the greatest. And then who else is close? Well, this is a distance of 1, and this is a distance of 5. And this is a little trickier because this distance is the square root of 1 squared plus 2 squared, or square root of 3. So we can see, and this is like a half or something like that. So B is definitely the strongest. The next nearest is A. The nearest after that is D. And bringing up the rear, C is pretty far away, so the intensity will be relatively low. Likewise, we'll do the distances for the rightmost point, and we see that this distance is about, let's clean up a little bit. This distance is 3/2. This distance seems to be 3. This distance is, again, I don't have to really refigure it, but this distance is root 3. And now this distance is 3. So we can see that the shortest distance remains that B is still the closest thing. D is very close, but is a little further away because 3/2 is 1.5 and root 3 is 1.7. And then we see that A and C are equidistant, and so they have the same intensity.